Morning, y'all. I want to show you instructions for your assignment today like I do every day. So today and tomorrow, you're working on something called periodic table exploration. Okay, it is a gizmo, but it's kind of a different way of doing gizmos. So first, you'll need to go to this link. Okay, so you'll have a worksheet right here to have open, and you'll click the link. And when you do that, you'll get this worksheet, and it'll take you to this gizmo site. The gizmo you need to be on is periodic trends. Okay, and when you launch it, it looks like this. This worksheet is asking you to do a little bit of exploration more than answering questions. Okay, it's a little bit more critical thinking. So the first thing you're gonna do, table 1, I'm sorry guys, I'm trying to film my screen, that's why I'm a little shaky. You're gonna look at atomic radius, ionization energy, and electron affinity. These are all new words. That is why I gave you the definitions right here to help you, okay? What you're looking at is the periodic table, and as you move across the periodic table and down the periodic table, what happens to the atomic radius, the ionization energy, and the electron affinity. Okay, so the atomic radius is just the measure of the electron cloud. It's the measure of the radius, okay, from the nucleus to the last electron, the radius, which is half of the circle if you don't remember. Ionization energy, the energy required to remove an electron from the atom. So how much energy is it going to take for that atom to give up an electron? Okay, that's what it's asking. And then electron affinity is the energy released when an electron is added to an atom. So if this atom steals an electron from someone else, how much energy is released? Okay, how happy does it get, essentially? So how you're going to look at this is you're going to go to your gizmo. If the first column says atomic radius, make sure this tab right here says atomic radius, okay? And the first section of your worksheet says what happens as you move down a group. So we're going down the periodic table. The great thing about this gizmo is all of the elements in the group with hydrogen are all right here. We don't have to click anywhere else. We don't have to go to the periodic table. It's here for your reference, but you don't have to click it. You can click down the rows right here. Okay, so we're gonna start with hydrogen. I'm gonna click show my ruler so that I can measure. Put one end on my nucleus and one end on my outside electron. And it tells me that my atomic radius is 53 picometers. I'm gonna click save. When I click save, it stays on the hydrogen. That way I don't have to remember it. So our question's asking us, what happens as we move down the group? So we're gonna go down. Let's go, skip one, let's go to sodium. Okay, I'm gonna drag it out to the last electron. My atomic radius is 190 picometers. Save radius. Okay, so now it saved hydrogens and it saved sodiums. Now let's keep going down, let's go to cesium. Boom, 298 is what that says. Save. So then you can look, what's happening to the radii as I go down? 53, 190, 298. They are increasing. So over in my box, I would write the atomic radii is increasing. As for why, don't forget to tell me why. Why is it increasing? Well, if you look, hydrogen has 1 electron, 1 orbital. Cesium has 55 electrons and 1, 2, 3, 4, 5 orbitals. 6 orbitals, sorry. 6 orbitals. If you have 55 electrons and 6 orbitals, you're going to have a bigger radius. You have to, or you wouldn't be able to hold them. So more electrons, more orbitals. That's why it's increasing. Okay? The next section asks about a period. So periods are across the periodic table, and the beautiful thing is they're all right here. Okay, so you can just click across and measure the atomic radii. Okay, you're going from the hydrogen side of the periodic table to the helium side of the periodic table. Okay, from left to right. All right. The next section of your worksheet asks you to find these specific elements, okay, and then tell me the number of protons, the number of valence electrons, which if you don't remember, valence electrons are the electrons on the outside ring. Okay, so let me get rid of my ruler so we can see this. So this is hafnium. I don't even know what that is, but hafnium has 2 electrons on the outside ring. It has 2 valence electrons. Okay? I don't know what that does. Oh, it makes it small. Okay, so it has 2 valence electrons. Then for group properties, this you will have to go back to the periodic table. So you click trends, and if you were looking at hafnium right here, okay, and hafnium lives in the yellow, so I would click on the yellow one and it tells me the group properties. That's what I write here, okay? And the group properties of hafnium: high density, malleable and ductile, high melting point, good conductors. That's because they're metals, okay? That's what I would write in that box. Then you have your atomic radii, your ionization energy, and your electron affinity, which we got from here, okay? And then your electronegativity, okay, which you get from here, okay? I think it's pretty self-explanatory. All of your answers come from the gizmo, so that's not too bad. The goal here, though, the last question I'm going to make you answer, I probably won't make you answer it till tomorrow, but is which element would be best to use to make a frying pan? Okay, so keep in mind that the reason we're looking at these is we're going to figure out which one would make the best frying pan. So pay attention to properties. If an element melts at a low temperature, it's probably not a good frying pan. So keep that in mind while you're doing this. Don't forget to do your daily questions and let me know if you have any questions.